So let's organize some of the things that we talked about in class today with respect to polar graphs, and being able to simply look at an equation and being able to do a quick sketch of the graph. This looks a little bit different than what you currently have in your note pack, so I'd like you to kind of change that. Right now I think it says a line through the pole and etc. But we're going to look at circles, and we're going to look at cardioids, and we're going to look at limacons. Okay, so we know that if we have the equation r equals a, we're going to get a circle centered at the pole, because I'm just going to start plotting in the polar curve, and I'm just going to plot all the points where there's a radius of 2. So r equals 2 would be a circle centered at the pole, okay, with a radius of 2. In that same vein, if I have r equals 2a sine theta, I'm going to get a circle that's centered around the vertical axis here, okay, because sine is the y value, and so we're going to center around as if this was in the coordinate plane, not the polar plane, and center around this horizontal axis. Okay, so for example, if I have the equation r equals 4 sine theta, because it's a positive 4, I know it's going to be up here in the positive area, and since it's sine, it's around the y-axis, and this 4 tells me the diameter of that circle. If we have in the equation r equals 2a cosine theta, okay, so since this is cosine, I know the circle is going to be around the horizontal axis, and since I have the equation r equals negative 4 cosine theta as my example, that negative tells me I'm going to be over in this area of my polar graph. And again, that 4 there tells me the diameter of my circle. So you need to be able to recognize the equation, polar equations of a circle, and be able to quickly graph those. All right, the next type that we're looking at is we're looking at cardioids and limacons. Okay, we have limacons with an inner loop and limacons without an inner loop. We didn't graph any of those without an inner loop today, but you'll see kind of an example one here that I've put in our note pack. Okay, so you'll notice that if I have the polar equation r equals a plus or minus a cosine theta, we will get a cardioid. And you saw one of those in your notes today when you were graphing them with your table partner. Okay, a cardioid happens when the number that you're adding is the same as the coefficient in front of the trig function there. Okay, and if they're all cosine, of course, they are going to be hugging that horizontal axis in some way. So here is the cardioid, and here's an example of a cardioid equation. R equals 2 plus 2 cosine theta. Okay, now this equation tells us lots about points on that cardioid. For example, we can see that the maximum r value that we're going to have is going to be 2 times whatever a is. So here's our maximum r value right here. That maximum r value is 4, which is 2 times this 2. We also are able to determine what our points of intersection are on the vertical axis. Our points of intersection on the vertical axis are going to be whatever a is. So for example, if I had the equation r equals 3 plus 3 cosine theta, my maximum radius would be 6. And then on the vertical axis here, I would intersect at 3 in both places. Now, of course, if this was 2 minus 2 cosine theta, this would just be reflected over here into that negative side. A limacon, you saw a limacon today. A limacon with an inner loop has the equation r equals a plus or minus b cosine theta. Okay, and so b and a are not the same number. Okay, so for example, r equals 1 minus 3 cosine theta. Now there has to be a specific relationship between a and b in order to get that inner loop. And that relationship is that a has to be less than b. Now note that b is without regard to the sign. Okay, b is always going to be a positive number. We might be subtracting b, we might be adding b. Okay, so in this case, 1 is less than 3. You don't say to yourself, well, 1's not less than negative 3. You take b without regard to the sign that's in front of it. So 1 is less than 3, so I know I'm going to end up with the limacon with the loop inside of it. I always remember that less than has the loop. Okay, so if a is less than b, it's going to have a loop. Now, a plus b, if I add a plus b, that's where I get that maximum radius. Okay, so a plus b, 1 plus 3 is 4. You can see my maximum radius here is 4. Then, if we do b minus a, we get the radius of the inner loop. So 3 minus 1, okay, is going to give me 2, and so that's the radius of the inner loop. Okay. Now a also tells me something else. A in this case will also tell me where I intersect on the vertical axis. Right? Okay, let's look at the next one. A limacon without an inner loop. Still the same form of the equation, a plus b cosine theta. However, this time, a is greater than b. Okay, so for example, 3 minus 2 cosine theta. It's a cosine theta, so we know it's going to be centered around the horizontal axis. It's a negative 2, so I know it's over here in the negative space. However, since 3 is bigger than 2, this is a dimpled, okay? It's a dimpled limacon. Okay? It's got that little divot in it. And again, a and b tell us some really important things. Okay? A plus b gives me that maximum radius. So a plus b is 5, so that gives me that maximum radius. And a b minus a tells me how far. So a plus b tells me this: 1, 2, 3, 4, 5. Okay, so from the pole. The maximum radius from the pole. And then a minus b tells me the minimum radius in the other direction towards the dimple. So a minus b, 3 minus 2 is 1. That's the distance from the pole to the little divot in the dimple. Okay, and then again, a tells me where I'm going to intersect on the vertical axis. Now we can make all those same conclusions with the sine equations. Okay, so here's some graphs for sines. So if I have r equals 2 plus 2 sine theta, again, we know that the maximum r value is 4. I know that it's going to intersect on the horizontal axis at 2, and it's going to look like a cardioid because a is equal to b. And because this is a plus sign, it's going to be up here in the positive area of that vertical axis. Okay? If I have r equals 1 minus 4 sine theta, looking at that, I see A is less than B, so it's going to be a limacon with a loop. It's sine, so it's going to be around the vertical axis. It's negative, so it's going to be down here in this negative region. And then I know that A plus B, 1 plus 4, is the maximum radius. Okay, 1, 2, 3, 4, 5. And then B minus A, 4 minus 1 is 3, is the radius of that inner loop. Okay, so the radius value to the tip of the inner loop. And then again, I know that A, which is 1, is where I'm going to, the curve is going to intersect the horizontal axis. R equals 4 minus 2 sine theta. A is bigger than B, so this is going to be a dimpled limacon. A plus B is going to be the distance from the pole to the maximum radius. So that's going to be 6. Now, this graph I made each piece 2. Okay, the scale here is 2, so that's 1, 2, 3, which would be 6. And then the distance from the pole to the dimple is going to be 4 minus 2, which is 2. And then again, here we are intersecting at the horizontal axis at A. Okay, so those are your general rules for limacons, cardioids, and circles, and we will take questions on that tomorrow, and then we'll go on and look, or not tomorrow, on Friday, and then we'll go on and look at Rose curves, okay?